In this 3-part video series, I'm going to discuss the capacitive touch timer project you see here. But first, let me show you around the finished device. It's battery powered and based on the same MCU that enables the Arduino UNO. A custom 3D printed case houses all the electronic components. You turn the device on by hovering your finger around the center of the top surface. You can then move your finger in a circular motion to set the time. First you set the minutes, then the seconds. Once the timer starts, it counts down the remaining time. When the time runs out, it beeps until the user touches the center button again. If the remaining time is greater than 60 seconds, the device shows the remaining minutes first, before displaying the seconds. You can stop the timer by touching the center button for a few seconds. Now let's discuss the circuit of this project. The project contains 3 individual PCBs, a power supply, the logic board, and the capacitive touch ring. The power supply of this device is a straightforward step-down circuit based on the 7805 linear voltage regulator. 2 smoothing capacitors accompany the regulator, and a standard 1N4004 diode protects the device from an incorrectly connected battery. The logic board is the most complicated part in this device. As mentioned, it's based around the same MCU that also enables the Arduino UNO. Therefore, the design starts with an 80 mega 32.8 PU. I then added a 10K resistor to pull the reset line of the MCU high. This prevents the device from constantly resetting itself. Next, I created this section that provides the clock to the microcontroller. I'm using a 16 MHz crystal together with 2 22 picofarad capacitors. Then I added 5 outputs that will connect the MCU to the capacitive touch ring. Each output is connected to a 36 mega ohm resistor. The other side of the resistor connects to another pin of the MCU. The firmware will send out a signal over the output pin and then measure how long it takes the signal to return. An Arduino library then calculates an arbitrary value that determines how high the capacitance is. The touch ring pads act as one plate of the capacitor, and if a user gets close to the ring with his finger, the finger acts as the second plate, forming a full capacitor. We can detect changes in the capacitance and make the program carry out an action if needed. I'll talk more about the firmware in part 2 of this series. For now, let's have a look at the display portion of the circuit. I used a MAX 7219 chip to drive the 2 7-segment displays that inform the user about the remaining time. I connected the displays accordingly, and then I added this 47K resistor that controls the current that the driver IC will send to the displays. As a last step, I added a capacitor close to the supply pins of each IC to help prevent brownout issues. Lastly, the capacitive touch ring. There's not a whole lot to show you here, as this PCB only contains thick traces that act as the surfaces used to detect touch input. Note that I designed the logic PCB to have 2 sides. The displays sit on the top side of the board, while the other circuitry is on the bottom side. In an earlier revision of this project, all components were located on the top of the board. This, however, resulted in the displays being too far away from the top of the plastic case, which made them hard to read. Note that the earlier version also lacked the capacitors on the logic board, which caused reliability issues. I also designed the board to allow you to use different sizes of capacitors. As you can see, I used low-profile electrolytic capacitors. However, you could also use taller ones and mount them horizontally, as indicated by the silkscreen. You can find a full bill of materials on my website. The link is in the description below. I didn't film the assembly of the PCBs, as the process is pretty straightforward. However, you can have a look at some of my older videos where I talk you through the assembly of PCBs in general. In the next part of this series, I'm going to discuss the firmware and how it works. Thank you for watching, and I'll see you in the next part.